Guys, how's it going? So today we're going to do some math for fun. We are going to find the derivative of secant x, but strictly using the definition of the derivative. And this might seem daunting, but I'm going to walk you through it. So first, I'm going to show you three formulas that I remember. These will come in handy later on. Lim of h goes to 0. I'm not writing the definition of the derivative here. I am only writing some formulas. So sine of h over h is 1. The limit of h tends to 0 1 minus cos h over h will equal 0. And lim as h goes to 0 tan h over h equals 1. Oh, wow, the marker is working really well this time, to my surprise. And if you don't believe me, use something called L'Hopital's rule. And where it's like, you realize, for example, tan h over h, you get a 0 over 0. Like anytime you get a 0 over 0, plus or minus infinity over infinity in the numerator and denominator in a limit, take the derivative of the numerator and the denominator. So then you would get secant squared h, the bottom would be 1, and secant squared h directly applies 0, and then you get 1. So just simple as that. So these are some nice things we can keep in mind for later. So first thing we're going to do, f prime x is equal to lim h tends to 0 secant, I know it's f of x plus h minus f of x over h, so I'm just going to directly apply it here. Minus secant x over h. Okay, so this, anytime I have to use the definition of the derivative to find the derivative of something, I like to just only consider sine and cos. It's the most basic functions in trig and easiest to remember. So let's just write it in terms of cos first. Lim as h tends to 0, 1 over cos of x plus h minus 1 over cos x all over h. And this almost becomes impossible to solve until you remember a formula you learned in pre-calculus 12. And it's like cos x plus h is equal to cos x cos h minus sin x sin h. This is just something you have to remember. Minus sine. Oh shit, I forgot the I forgot to do the lim h tends to 0 shit. Crap. Okay, and I don't really know how to edit, so that's fucking awesome. Lim h tends to 0. 1 over what I just said earlier. There's a formula. Yeah, cos x cos h minus sine x sine h. I know how to take the definition of derivative of anything except for the arc, the inverse trigonometric, like the arc sine, cos, and tangent. I'm sure you can't find it directly through the definition of the derivative, but there's other ways. Okay, so you have this. Now we're gonna have the find the lowest common denominator of these two denominators. So let's just go do that right now. Lim h tends to 0. Okay, so 1 over, we're going to multiply the numerator and denominator here by cos x. So that's it's cos x over, okay, you're multiplying the entire thing by cos x, cos squared x cos h minus sine x cos x sine h. And minus 1 over, sorry, no, we're 1 over cos x, but multiplying this denominator. So take the eraser and draw again. So, okay, so that would be cos x cos h minus sine x sine h. Over this stuff. So cos squared x cos h minus sine x cos x sine h. All over h. This is the numerator. Do not get confused here as to what we are doing. Okay, so, and that equals, do I even have enough space? I don't think I do. As h tends to 0. So cos x cos h, I'm gonna write in more steps. I don't really want to make a mistake. So cos x minus cos x cos h plus, because minus and minus becomes plus, sine x sine h all over, and because the denominator is like this, I'm going to say h multiplied by all this we mentioned earlier. So cos squared x cos h Yeah, cos squared x cos h minus sine x cos x sine h. So there you go. We can simplify this. We can break it up. Okay, so cos x, like cos x, 1 minus cos x, oh no, 1 minus cos h over h. I'm going to do something like this so you guys don't get confused. This limit h tends to 0 of all this stuff I'm going to write afterwards. Plus sine x sine h sine h over h times cos squared x cos h sine x cos x. You get the idea. I don't feel like writing it a second time. I don't feel like writing it a second time. Okay, and we can use the formulas. Remember what I said earlier about 1 minus cos h over h being 0. So then all this cancels out to equal 0. And then sine h over h cancels out to equal 1. So you're left with lim as h tends to 0. And your sine x on the top in the bottom, you have the cos squared x cos h minus sine x cos x sine h. Now you no longer have an indeterminate value, so you can directly plug the h equals 0 into this function here. So then sine h, this just directly equals 0. And cos h, that just equals 1. So you're left with sine x, sine over cos squared x. Which equals 1 over cos x times sine x over cos x when you break this down. So you get secant x tan x. And that is done. Now, so I have a practice for you. I have a few practice. Find the derivative of tan x and sine x. And using what I said earlier. So remember, I only use sine and cos when finding the definition of the derivative of this. And f prime x of sine x. Just using sine and cos, guys. And when you get it right, you will find that this is equal to secant squared x. And that this will equal cos x. So there you are, all done. Now I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.